Hello and welcome back to Under the Apple Tree, and today we're going to be going over some differential equations, in particular one method called the integral factor. And this one can be kind of tricky the first time you see it, but after a lot of practice it becomes really routine and mechanical and not so bad at all, actually. So let's go ahead and just jump right in. So we're given a differential equation, dy dx minus y over x equals 8x times e to the x. Now there's a very particular way you want to set up this equation before you get to solving it. So I'm just going to underline these two terms here. And the reason is, let's you do this blue line here. And the reason is you need to set you're going to have sub functions inside of your main function. Let me explain. So this underlined green one that I have over here, this term, you're going to want it to be on the same side of the equation of the equal signs as dy dx. And you want it to be a y and an x. It doesn't matter, y over x, y plus x, y times x, doesn't matter as long as they're together on the left side of the equation. On the right side, you're going to want something that's only a function of x. It's very important. Now, I'm going to rewrite the equation like this. And you basically want to separate your y and x. We're going to change this to 1 over x times y. And then that equals 8x e to the x. Okay. And so now, I don't know exactly what letters you learned in your lecture, but I'm going to use P and X, or P and Q, I mean. So let's underline this in green, underline this in blue, just keep it going. And the green one is going to be P of X. P of X is equal to negative 1 over X. We have a negative here, 1 over x here, everything except for the y, basically. And then q over x, or q of x, sorry, is just equal to everything on the right side of the equation. 8x e to the x. Basically, there's a function that we're going to plug, a formula that we're going to plug these into. And there's another formula we have to use, and that formula is basically where this method gets its name from. Mu of x is equal to e, the integral of p of x dx. What's our p of x? Negative 1 over x dx. And basically we're going to integrate this and we're going to get natural log. Hopefully you have those basic integrals down. This is not going to be fun at all. So we have e to the, pull out the negative, natural log of x. Okay. E's in the natural log, e and natural log cancels out. And if you have a negative natural log, that means you get a negative exponent in the argument here. So that just means you're going to get x to the negative 1 as your answer. But x to the negative 1 is just the same as 1 over x. So our mu of x is equal to 1 over x. Okay, so now we have a mu of x, we have a p of x, and a q of x. And when you're doing integral factor, if you have all three, you're pretty much exactly where you want to be. So the main formula that you're going to plug this all into, y equals 1 over mu of x times the integral of mu of x. Oh, let's redo that there. Times mu of x times q of x, and then dx. So normally when you plug in mu and q, something cancels out really nicely, and When you get some nice cancellation, that's a pretty good sign that you're on the right track. Okay, so if we plug in 1 over mu of x, well 1 over x is just x. So x times the integral mu of x, which is just 1 over x, q of x, we have that over here in blue, that is 8x times e to the x dx. And that's going to be a really, normally what happens is you get a really nasty looking integral, and then something cancels, and then it's not too bad of an integral. So our x's cancel here. So we're going to have the integral of 8e dx. So we can just pull out our 8 and take the derivative, or take, sorry, not derivative, take the integral of e to the x. And remember, e to the x doesn't change. It doesn't matter if you differentiate or integrate. So y is just going to be equal to 8x e to the x plus some constant. The constant of integration, we don't know, and we're not given any information to find it out. So this would be our final answer here. Okay. Let's go on to the next one. So we're given dy over dx plus 3y minus 7e to the negative 2x. And we're also given an initial condition, y of 0 equals 10. Okay, that's going to help us find the constant of integration. Hopefully like it's no big deal finding the constant of integration. That should have been learned in differential calculus, and it should be pretty easy. The hard part is the integral factor part, which hopefully I can help you understand. So we're given dy over dx plus 3y minus 7e to the 2x. So what we want is one term that has an x and a y, and then another term on the right side of the equation that has only x's. And this 7e to the negative 2x is only x's. So let's move that over. Dy dx plus 3y equals 7e negative 2x. Okay, so let's write down our p and our x. So remember in this last question, I underlined this term here, and then I pulled out the x and separated it. But in this one, we don't have an x in this one. So what we're going to do for our px is we're just going to say, well, px is just 3. Everything except for y, and that's just 3. Now our qx is just going to be this term, this whole entire term on the right, 7e to the negative 2x. Okay, so we have our p and our q. Now that means we can find mu. So mu of x is equal to e to the integral of px. Px in this case is just 3 dx. And that means mu of x is just going to equal e to the 3x. Very easy integration here. That's e to the 3x. I know the 3 is written poorly, but e to the 3x. Now we have a mu and a q. That means we can solve our main formula here. Y equals 1 over mu. But instead of writing 1 over e to the 3x, I think I'm just going to write e to the negative 3x. Same thing. Integral of mu, e to 3x times q. Q is just 7 e to the negative 2x. Now in this case, there's no x's to cancel out. Remember in this one, here the 1 over x times the 8x, the x is canceled nicely, and we didn't have a nasty integration to do. But in this one, we can't cancel any x's, but we do have like terms we can cancel our e's. So let's do y equals, I'm going to pull out the 7 out front, 7e to the negative 3x, and so we have here an e to the 3x times e to the negative 2x. And we're just going to add the exponents, and we're just going to get the integral of e to the x times dx. And this e to the x is just going to stay the same. Remember the integral and derivative of e to the x, it doesn't change the function. So let's do, when we integrate, we get e to the x times 7e to the negative 3x. You add those exponents, and you're going to get 7e negative 2x. And remember, we have to add our constant of integration plus c. That is a plus, not an asterisk, plus c. Okay, now we can plug in our initial condition. Y of 0 equals 10, so 10 equals 7e to the 0 plus c. E to the 0 is just 1. We can subtract 7 over 10 minus 7 is just 3. Constant of integration is equal to 3. And that means we can plug it in and write our general equation for this differential equation. Y is equal to 7e to the negative 2x plus 3. That is our answer. Final answer. Alright everyone, so hopefully I helped you improve your knowledge and comfort with solving integral factor method for differential equations. Differential equations is a very hard subject. Do not feel bad if it doesn't come to you easily. It's probably the hardest math class you'll take if you're an engineer. So yeah, no worries. Just keep practicing. I'll probably make another video with integral factor just to pump out some more examples. But anyway, guys, this is gonna do it for this installment of differential equations. I've been Under the Apple Tree. Have a good one.